are further away. The problem was that Paczynski's observations seemed to require explosions with more energy than any star had ever produced.
If you took a model that would work at the distances Baudin was describing, you would have to convert 1 million Earth masses into pure energy instantaneously, well, within 10 seconds anyway, and in the form of gamma rays, and get it out, and get it 3 billion light years to us. And so, yeah, okay, Baudin, maybe, but be good. Work on something else for a while.
In 1991, NASA launched the BATSI satellite. Equipped with state-of-the-art detectors, it was going to study the bursts in detail for the first time. But as the data came in, a disturbing picture began to emerge. What they'd expected was that the bursts would line up with the galactic plane, meaning they were coming from within our own galaxy.
The first dozen or so gamma ray bursts weren't lining up with the galaxy. The next dozen or so also weren't lining up with the galaxy, but they happened to be randomly distributed throughout the sky.
There was now no doubt. Paczynski had been right all along. But Paczynski's triumph threatened to plunge science into chaos. If the bursts were coming from beyond our galaxy, then they had to be caused by something far bigger than science could explain.
If they were really coming from distant galaxies, it was a phenomenon unlike anything we've seen before. The amount of energy release, the rate of energy release, was greater than anyone had ever seen before in any other form. And the details of how you got that, nobody could understand how that could be. It was pressing the limits of our understanding.
It was now clear that these explosions were of an almost inconceivable size. So big, in fact, that they might even be violating Einstein's fundamental law, E equals mc squared. And that was meant to be impossible. It now became imperative to get an accurate distance measurement of the gamma ray bursts. Scientists turned to the only technique they had for precisely measuring how far away objects are from Earth. A technique called redshift.
Redshift is a fantastically important tool for astronomy. Basically, measuring the redshift to an object is what tells us the distance of that object in astronomy. And the distances that we're talking about are so vast that they're extremely hard to measure by any other way, but redshift actually turns out to be quite straightforward.
Most explosions cause a flash of visible light. Scientists can split this light into its spectrum of colors. The further away an object is from Earth, the more red the light looks. The problem with gamma ray bursts is that they produce no visible light, so they cannot be redshifted.
Even today, we cannot focus gamma rays. There are no lenses that will make an image in gamma rays.
But then they realized that when the gamma rays blasted out, they would pass through all the gas and dust floating in space. This material would be heated up and would glow. This afterglow would be visible and might last for several days. If they could find it, it could be redshifted.
If we could ever find just one glowing ember of a gamma ray burst, the mystery would be cracked open, because we'd have a location and we could go look with the full panoply of radio telescopes and telescopes in space and big telescopes on the ground.
The hunt was now on for the afterglow. On the 9th of May 1997, a very bright gamma-ray burst was picked up. All over the world, telescopes were being reprogrammed and refocused in the hope of catching this elusive afterglow. And then it happened. A faint flash of light was spotted. The astronomers analyzed the light. It wasn't at the blue end of the spectrum, suggesting the burst was from inside our galaxy. The light wasn't even green. The yellow would have indicated that the bursts were coming from far outside our galaxy, but it wasn't there either. This light was so far towards the red end of the spectrum that the burst could only have come from further away than anyone ever imagined.
Redshifts proved conclusively, beyond any doubt, that they were coming from the edge of the universe and nowhere nearby.
So the gamma-ray bursts were coming from the other side of the universe, 10 billion light-years away. No star could be big enough to produce that amount of energy.
If you took all of the stars and all of the galaxies and all of the quasars and everything in the universe and put them all together at one point at the distance of a gamma-ray burst, it would not be as bright as the gamma-ray burst.
It meant that they were being produced by explosions that didn't just test Einstein's law to its limits. They completely shattered it.
The amount of power involved to produce a bright flash detectable literally 10 billion light years away was a remarkable source of energy and remarkable phenomenon that we really had to try and explain.
Scientists were stunned. Now they were confronted with something that was physically impossible.
What was mind-boggling was how that much energy is converted into gamma rays, because the amount of energy was so large that people felt, my goodness, maybe new physics is required.
For a brief moment, it seemed that E = mc squared was wrong. And if a law as fundamental as that was wrong, then perhaps everything we understood about the universe could also be wrong. Someone had to restore order. The man who came to